Okay, last part hopefully of this very long video. Just finish this off very quickly. We do need to take a 2 outside there, look, because it says to fully factorise. Okay, you're going to get 1 mark for what you did above, which is a bit mean seeing all the work we did. Okay, 13. Probably thinking, why is there a circle on a non-calculated paper? Well, it's in terms of pi, so don't panic. We've got a square. That's 8 times 8. The area of that is 64, not a problem. Okay, then we've got a semicircle. Now then, to work out its area, we'll need to know its radius, and its radius is 4. The formula for a circle is pi times r squared. That's pi times 4 squared. 4 squared is 16. In terms of pi, that is 16 pi. But of course, this is the formula for a full circle. We've only got a semicircle. So we do need now to divide that by 2, and half of 16 pi is 8 pi. So the semicircle on the top has an area of 8 pi. What is the total area? Well, it's 64 on the bottom plus 8 pi on the top. There's nothing you can do with that. That's finished. Okay. Then we've got down the bottom of that page a little bit of indices work. Anything to the power 0 is 1. That's why it's only a mark. Okay, and we've got some standard form with dividing. So we need to divide those and take away those. It doesn't get much worse than this. Okay, well, if it was 9 divided by 4.5, that would be 2. But it's not 9 divided by 4.5. It's 4.5 divided by 9. That's a half. Okay, so the first bit there gives us 0.5. Then we've got, it's not 12 take away 8, that would be too easy. It's 8 take away 12, so that's minus 4 for the powers. Okay, that's worth nothing because you can't have 0.5 in standard form. This needs to be made bigger, 10 times bigger, so that changes to a 5. This needs to go smaller, and smaller than minus 4 is minus 5. So in standard form, there's your answer. You get no marks for this, I'm afraid. Okay, you can't have 0.5 at the front. Okay, this is again a numeracy topic really. It's upper and lower bounds. The rules are for upper and lower bounds, whatever it says to the nearest, it's half of that up and down. So add 50, take away 50, or nearest hour, add half an hour, or take away half an hour. So the least distance travelled is 3,000, take away 50, 2,950, and the greatest distance is 3,000, add 50, which is 3,050. Okay, for the time, it's 80 take away half an hour, 79.5, or is 80 plus half an hour, 80.5. We're working decimal time. Okay, now then, that would be horrible maths to work with without a calculator, but it says you do not need to calculate on the next part. So not looking for an answer, just want to know what you would do. To give him the greatest average speed, now remember speed equals distance over time. To get a big answer for that, I want the biggest distance divided by the smallest time. So the calculation would be 3,050 divided by 79.5. We do not have to work that out. Okay, but to get the greatest speed, you would do the biggest distance divided by the smallest time. Okay, for the second part of this question, Klaus bought a new car. He did 60 miles in 2 hours. He did X miles in Y hours. The times are fine, so nothing wrong with the times. You can leave the times alone. That's fine, that's fine. The distances is to the nearest mile. Nearest mile means add a half or take away a half. And it says to calculate the least value for the average speed for the 2 journeys combined. Again, speed equals distance over time, but because he did 2 journeys, it'll need to be the combination of both journeys, the total distance and the total time. Okay, so the 60-mile journey, it may have been 59.5, it may have been 60.5. And the X mile journey, a little bit tricky here. You'll have to write this X take away 0.5 or X plus 0.5. We want the least value for the average speed. That would be the smallest distance divided by the biggest time. So the smallest distance would be this one and this one added up. So we've got 59.5 plus x, take away 0.5. Now that's the same as just doing 59 plus x, all divided by the biggest time. Well, we can't have a big time. The time was accurate. The total time is 2 hours for the first journey and y hours for the second journey. 2 plus y. There is no big and small. It's just 2 plus y. Okay, and again, there's nothing to work out there. We don't know what x and y are anyway. Okay, but it's just mucking around and checking, you know, how speed works. Big divided by small and small divided by big. What have we got here then? We've got some identical pebbles, and you've got the word similar in bold, and hopefully you see the word similar and you think scale factors. And then you see you've got volumes and lengths all mixed up. Okay, so it's going to be a sort of an LSF, ASF and VSF question. Okay, right, we've got pebbles with a volume of 2 centimeters cubed. So the small pebbles are 2 centimeters cubed and the big pebbles are 54 centimeters cubed. All you can do is divide those. They are volumes. So when you do 54 divided by 2, which is 27, what you've found is the VSF, the volume scale factor. Now then, the question is, if it takes 15 small ones, how many big ones would it take? Now that all depends on the sort of the length of the larger pebble. Okay. Now we don't have a length for the smaller one, but what we can do is work out the linear scale factor. To get from volume scale factor to linear scale factor, you cube root. The cube root of 27 is 3. In other words, these larger pebbles are 3 times longer. So if I call it L, 3 times longer, 3L. If they're 3 times longer, then I only need one large pebble for every small pebble. Which means if it took 15 small ones, it will only need 5 big ones because they are 3 times longer. So it will need 5 large pebbles to go the same distance. Okay. This is converted into standard form. So 2.1 times 10 to the power of minus 2 is a small number, minus power. So if we start there and there and put my decimal point there, it's 2 jumps. 1, 2, 0.021. Okay, that's easy enough. 400 to the power of minus a half. That's a little bit trickier because this is indices. So the half means to square root. The minus means 1 over. So it's 1 over the square root of 400. That's 1 over 20. Okay, you're not quite finished though. It says to give your answer as a decimal. Well, 1/20th is 5%, 0.05. Okay. And then we've got 12 over 99, so clear decimal. The only way to do this is to do some long division. It's 12 on the inside divided by 99 on the outside. 99 won't go into 1. 99 won't go into 12. So you have to put a 0.0 on the end and keep going. Now 99 does go into 120. It goes in once, remainder 21. 99 goes into 210 twice, remainder 12. Once, remainder 21, twice, remainder 12. And what you'll start to see now then is the repeating pattern of 0.1212. So it's written like that as a recurring decimal. And then the third question, it's asking us to work out root 5 times root 7 times root 70, and it's telling us that in our answer there must be a root 2. So do they want you to do 5 times 7 times 70 and then find a square number? No, they don't. What they want you to realise is that 5 times 7 is 35, and 70 can be made up with 35s as well. 35 times 2, which is where the 2 comes from. Okay, so that's that part, that's sorted. What happens when root 35 times is root 35? Well, a neat little rule of thirds is that if you've got the same third multiplying, it just loses its square root sign. So root 35 times root 35 is 35. Okay, if it looks like they're asking you to do something horrible with thirds, there's probably a shortcut. Nearly done. Okay, y inversely proportional, so 1 over x, put a k in with an equal sign. 50 is equal to k divided by 2. To get k on its own, we bring the 2 up and multiply, so k must be 100. You're not finished yet. You need to go back to here and say that y is 100 over x. To get all 3 marks, you must go back up. And then using that formula, y equals 100 divided by a half. How many halves make 100? 200. Okay, and then here 12.5 is 100 divided by something. Swap them round. 100 divided by 12.5, well, 25 would go in 4 times, so 12.5 goes in 8 times for that question. Okay, histogram now then. Probably better I start a new video for this one. I'm never going to get this one done in 2 minutes. Yeah, we'll do another video. So I'll see you in part 5.